Oh, hello there. I'm just rounding some numbers here. Well, let's round numbers together. IB style. Let's start with the reason why we need to round numbers. Well, first of all, some numbers are always changing and it's impossible to report certain numbers. For example, here's an example that I just found very recently, and that's population of the world. So what is the population of the world right now? And how do you report this without rounding it? So let's take a look at this together. So this is the current world population. As you can see, it's constantly changing. I'm gonna try to catch it when it's there we go. 7,257,224,630. Oh, now it's at 40. So as you can see, it's almost impossible to report this accurately without rounding it. So what we usually do is we report it as a number in the billions, or maybe in hundreds of millions, but not to the hundreds. So that's called rounding, and you've probably done this before when you were younger. Basically, the way rounding works is as follows. So let's just pick a number and we'll use it as an example. I'm going to pick number pi because I like pi. I like me some pi. And this is what we're going to use, 3.14159. Obviously there's more, but we're not going to concern ourselves with this. And we're going to round it to, let's just say, let's start with this here, which is what, 1,000th of a number? Basically 4 significant digits. When you're rounding, you have to always look at the number afterwards, and afterwards we have 5, and that's actually quite a tricky number because some people think that, well, listen, 5 is in the middle, how do you round this? And so this is how we usually do it. So let's look at this beautiful picture with a car and a hill. Imagine you're going up the hill and you drive in your car, or you're pushing your car up the hill, and then you get to somewhere over here almost up to 5. And then you get out of the car, and what happens to your car? Well, your car rolls downhill, and that's a good way of remembering that. Anything from 0 to 4 goes down. So basically, if this was a number such as 3.1414, then we would actually cross this out and keep 1 as just 1. So it would just be 3.141. Now, once you get to the 5, once your car is right here, and everything after 5, if you were to get out of your car right here, it would roll the other way. It would roll toward the higher number. So in other words, you would round it up. So because this is a 5, or if this was a 6, 7, 8, or 9, this will become a 2. And so what we get is 3.142. And this is pi to 4 significant digits, or we can also say to 3 decimal points. In other words, just to summarize this, so as you can see, I just drew the numbers here, and if you just draw a vertical line right here separating them, everything on this side, the number doesn't change, and then everything on the other side, the number goes up by 1. And that's something that you should already remember, and if you forgot, hopefully this helps you recall this. Now let's take a look at the IB style rounding. Now, by default, if nothing else is mentioned in the question, you will always round to 3 significant digits. And I'll explain to you in a second what this means. Let's look at pi again, and I'll show you what the significant digits are. 3.14159. Now, to find a significant digit, the first significant digit, you have to look at the number from the left. So you start from the left, you go right, and anything that is not 0. In other words, is here. This number 3 right here is your first significant digit, meaning that this right here is your second significant digit, and this right here is your third significant digit, 1, 2, and 3. So if you were to rewrite pi in IB terms, it would have to be just 3.14, and this is what we already know. Now, what if it's a number like this? What if it's 0.07000245? How would you find 3 significant digits here? Well, once again, you start from the left. Let's go from the left to the right, and you have to count everything but zeros. So this is a 0, so that's not a significant digit. That's a 0, not a significant digit. This right here is your first significant digit. Now, everything after the non-zero significant digits starts counting as a significant digit, including 0. So in other words, these zeros right here start counting toward significant numbers as well. So that's 2, and that's 3. So if you were to rewrite this to 3 significant digits, it would be 0.0700. Now, so once again, if the first zeros are not significant, so these zeros right here are not significant, but zeros after your first digit become significant. So these guys are significant. So we don't just cut them out and write 2-4, but we actually have to consider them as well. And there are actually 3 different ways of rounding numbers. So the first one that we just talked about, this is called significant digits or significant figures as well. It's actually interchanged. And if the IB doesn't ask you how many significant figures you have to write, then you always write 3. So in other words, 1, 2, and 3. So by default, it's always 3. If it asks you to find 4, then you have to add 1. Now there's also something called decimal points, and this is slightly different. So sometimes you'll be asked to find something to, let's just say, to 2 decimal points. Now in this case, what you're looking for is you're looking for the numbers after your decimal point, which is why it's called a decimal point. So for example, once again, let's go with pi, and your question is find this to the 3 decimal points. So, and we have something like this. So where are the 3 decimal points? Well, you look at the decimal point right here and you start counting. 1, 2, and 3. In other words, the answer to this question will be 3.141. And this is pi to 3 decimal points. If I were to combine these two, number 1 and number 2, basically what you'll get is that decimal point is the same as significant figure minus 1. So 3 significant digits is actually 2 decimal points. However, that's only for numbers that have decimals. Sometimes you'll have significant digits that have no decimals, and we'll take a look at this after this example. And you'll also sometimes be asked to find number to, let's just say, nearest tens, nearest hundreds, nearest thousands, or when we're looking at the example of world population, nearest billions or nearest hundreds of millions. So let's find pi to the nearest tenth. So this is our example. Find pi to the nearest tenth. So let's rewrite pi again, 31415,159. And now this time we're actually looking for the tenth, which is right here. And so if we were to rewrite this to the nearest tenth, it would be 3.1, just 3.1. This is to the nearest tenth. If you're asked to find this, here's the trick examples. If you're actually asked to find this to the let me use a different color, nearest tens, not tenth, but tens, nearest tens. So in other words, numbers like 20, 30, 40, 50, how would you rewrite this? So this is a tricky question. And here what we're looking at, so we're looking at pi in terms of tens and 20s and 30s. And you have to actually round it down to 0. So in other words, if it's nearest tens, pi is just going to be 0 because it's 3, which is the closest to a lower number, which is 0. If this was a 5 or a 6, we would round it up and it would become a 1. But unfortunately it's not, so it's a 0. So pi to the nearest tens is actually 0. So let's try one of the examples that I just found online in one of the previous IB manuals. And example is this. You have a square root of 2 and you have to find 3 things. Number 1 is you have to round this to the nearest 10 again. Nearest 10. Number 2 is you have to find this number to 2 significant digits. 2 significant digits. Or significant figures. And number 3 is you have to find this to 2 decimal points. 2 decimal points. And we're going to use our GDC, our calculator, for this because, I mean, square root of 2, it's an irrational number, it's a pretty long number, and if you don't remember what it is, you may as well just use your GDC. Okay, so let's find our square root of 2, and the answer is 1.41421356.2. So let's start with the number 1. What is this to the nearest 10? So just like pi, we have to round down. So let's actually just rewrite it first. So let's rewrite it here. Alright, so that's our answer from the GC, 1.4142. And the first question is to the nearest 10. So once again, we're looking at the number that's right before 1, so not at 1, but right before 1, because these are the tens. And because we're rounding this, we're actually rounding it down because it's a 1. It's not a 5, it's not a 6, it's a 1, so we have to round this down. So in other words, this will become 0. And the answer that we'll have will be 0. Alright, let's try second question, and that's two significant figures. So I'm going to write number 2 right here. This was our number 1. And we're looking for two significant figures inside our square root of 2. And that's our first significant figure right here. And this is our second significant figure. So the answer will be, I'm going to write it in yellow, 1.4. And the last question is 2 decimal points. 2 decimal points. So let me just rewrite this because this is getting kind of messy. So one more time, 1.4, 142, and 2 decimal points. So this is a decimal point right here. This is our first decimal point, second decimal point. So the answer is going to be 1.41. Now, do we round this up or down? We keep it the same because this is a 4, it's not a 5, so 1 stays the same. And the answer is this. And that's pretty much it for the rounding IB style and how to round to decimal points, to significant figures, and to nearest tens, thousands, hundreds, and so on. Hopefully this was helpful, and good luck to you. See you later. Bye-bye.